So I'm going to talk to you about Kaleidoscope, do a little bit of an intro, and then kind of go into a demo of the tool. And then I've got some other slides with some big kind of takeaways and how we use it in our practice. So we kind of just created Kaleidoscope out of this question that we had constantly in our practice. You know, we're always asking, well, which of these materials is more aesthetically pleasing when we're looking at facades or, you know, other aesthetics. But in reality, we need to really be also asking, how do these impact our, you know, embodied carbon choices? And we all know this, we're on the call, but we were finding that it was really taking us a lot of time to kind of like go into the existing tools and create these options. And then by the time we had the data, the kind of time for those decisions had passed. So that's how we decided to create Kaleidoscope based on kind of these common assemblies. And it started with envelopes. And it's really about bringing that, you know, preliminary design, kind of like how Brad was also saying for the Epic tool, you know, similar, that we need to make these decisions early. And this is to help with that. And so we use Tally to run all of our data. So you can replicate all of this through by doing your whole building LCA as well. So this is kind of the splash page of Kaleidoscope when you first get there. We have added a tour for kind of an introduction if anybody is kind of confused on how to use it or needs an intro. We have envelopes, which is the first assembly that we created. And then we have over time, it's been Kaleidoscope been public for about 3 years, but over time we've been adding to it, and we have added flooring and ceilings. And then just earlier this month, we also added partition assemblies. And so what's important about Kaleidoscope is that everything is apples to apples, and you can actually compare all of these. And so especially with envelopes, we designed them all to be the same R value at the time, the code value of 15.6. And so that way you're not looking at that operational energy kind of factor. And so, and then all the other systems as well, the interior ones we're all modeled with the same system boundary, and then all the data is normalized per square foot or in partitions per linear feet. And so we decided to start with the envelopes because that was kind of a big question and kind of the biggest piece of that carbon pie that we as architects have a lot of control over. And then we kind of moved into finishes, and within finishes, you know, we see kind of flooring, ceilings, and walls as the big pieces. And, you know, we might over time add more categories, but currently this is where we're at. And so this is what Kaleidoscope looks like. Right when you go there, we have all the data kind of down here. This is the area that we're calling, I don't know if you can see my mouse, but at the top we have what we're calling the lenses, which is why it's called Kaleidoscope, because there's multiple ways you can view the data. And so one of the big lenses that we have that we think is really important is the lifespan. And so we have an initial carbon lens, which is only looking at module A and kind of for basically a 1-year lifespan. And this is to try to understand, you know, that time value of carbon, and the decisions that we make now are more important. And so this is the lens that we choose to look at our data, but we also have a 60-year lens with and without module D for when you are doing your whole building LCAs, and you can consider those as well. We also have an all impacts lens. So in addition to just global warming potential, we have kind of a normalized weighting system of all the life cycle impacts, because those are also important, and we don't want to kind of ignore those. And then we also have a lens that you can toggle on and off with biogenic carbon. You can kind of click this little question mark up here to kind of get more information. And we recommend that you only use biogenic carbon if you're, you know, sourcing FSC wood or other responsibly sources. And that kind of shows up as a negative here. In this, and we also have this material breakdown chart, so you can start to see where the different pieces of the assembly you're getting the most carbon, or the most carbon's coming from. And then in addition, in our interior assemblies, we have this material health impact lens, which basically follows our Payette material policy to help our designers to select materials that don't contain these classes of chemicals based on the 6 classes. And as well, there's a little area that you can pop out and get more information. And we have kind of information there as well, more details about that material health lens. And then so to go to the tool and actually show you that. All right. So this is the web page. Right when you get there, it's going to look like this. It's payette.com/kaleidoscope. And you can see that kind of splash page right here to kind of enter into the tool. But in addition, we have a lot of information down here as well. We have more info about our kind of foundations and how we created it, the methodology, as well as information about each of the systems. And on the sidebar here, we also have a bunch of resources, our awards that we've gotten, links to different blog posts and presentations. So you can read through there to get more information as well. And then so you click on one of the assemblies to get into Kaleidoscope, and you can then toggle back and forth between the different ones once you're within it. And you can scroll down to see all the different kind of subcategories within each of these. This is for envelopes. And we also have a kind of hover state here that tells you a little bit more information about each one with the little axon, and just some basic info. But we also have, if you click over here on the side, we have kind of a larger detail of what was actually included, as well as that kind of donut chart breakdown, and then a list of kind of our assumptions that we included too. And you can also kind of uncheck the options that you're not interested in looking at, or you can kind of clear them all and just select the ones you want to see, or you can select them all. And they all kind of have this pop out. And then at the bottom, we also have this calculator, and we have this for everyone, every different assembly, and you can add rows, you can add options, and here you can start to compare different options for embodied carbon very simply. And then so you can see kind of the other graphs here, this all impacts. We have that life cycle stage here as well. So this is going to show kind of the different, modules that your embodied carbon is actually coming from. And it looks different once you start to click on the kind of 60-year lifespan. So you can start to see that module D credit that you're getting there. And so you can see some of the other systems that we have here as well. And partitions is the one that we've just added. We have glass partitions and CMU, and then there's a lot of different permutations of metal studs as well as wood studs. And again, you can kind of click on these and see some of the details that were actually included. So that's the basics of how Kaleidoscope works. Is pretty straightforward, but within that, we found that there's kind of a lot of information that we can kind of take away in how we use it. And so just to do super brief, so this is an example with envelopes that we like to use that, often we're comparing different kind of parties and visual aesthetic styles. And we can quickly pop in the square footages of each of these into Kaleidoscope's calculator and try to understand which of these actually has a better embodied carbon option. And in this case, from this kind of baseline, that's all granite, we can actually see that this option 3 is going to be the best option, where we're actually using a switching from the masonry veneer to a rain screen and granite here. And from those two options, we can get a 54% reduction in embodied carbon with just this envelope, which is pretty significant. And we're able to do that by maintaining the same aesthetic, but because granite has such a high embodied carbon, switching from that 4 inches of veneer to the kind of the 1/4 inch with the honeycomb panel, we're getting that similar aesthetic, but we can actually save a lot of carbon. So we're not compromising on maybe what we'd originally had that vision. And we actually used this on a project when we were doing that analysis. We had a project that had a 4-inch limestone veneer, and we were able to make some changes to the design without totally changing everything. We were just able to reduce the thickness of those masonry veneer pieces and get an overall 1% reduction in our whole building LCA from that decision, which contributed to us getting the over 10% reduction for the lead points. We also use this, a lot to just compare different materials when we're looking at, this is done in early SD on a project. We were just looking at different aesthetics, and we could quickly pop in, is it an ACM panel, or is it a zinc panel, or ultra high performance concrete? And we can kind of see what those differences are. So then some main big takeaways, is can you get that same aesthetic with a smaller amount of material? And those details, we kind of noticed a lot of trends. The rain screens, the lighter ones tend to have a much lower embodied carbon. So those details and those support systems do matter. And maybe if you really, really want to have a high embodied carbon material like that granite masonry, or, you know, some of the curtain walls, be mindful and strategic about where you place it. We're not trying to say, don't put this stuff, these items in your, you know, we're not trying to restrict your aesthetic palette. We understand, I guess, as architects, aesthetics do matter to us, but maybe be, you know, don't put it everywhere. And then for flooring and ceilings, we've kind of had some different conversations about this, that it really more has to do with kind of that lifespan and the replacement rate once you're starting to look at interiors, because they have a much shorter lifespan. So we think this is for a 60-year lifespan, and these kind of tick marks here are showing the replacement rate of items. So carpet has a pretty high replacement rate. So this is something that, you know, you should be considering based on, you know, maybe select your embodied carbon of your interior materials a little bit based on what the use is going to be and the tenant and how much you think they're actually going to get replaced. We noticed also that wood species tends to matter more when you're looking on these smaller scale of materials. The different growth rates of wood actually plays into some of the slight differences in embodied carbon that we notice when you're looking at something like a ceiling, a wood grill. So that's something to consider. And also, obviously, with interiors, that economy is often the most sustainable. Having an open ceiling with less material, you know, maybe with the acoustic spray or just painted, is going to have a lot lower embodied carbon than something that has a whole metal structure holding up kind of your baffles. And then so partitions is the latest one that we've added. And we found that there was actually a lot there that we didn't initially expect. And so when you're starting to add interior partitions into your LCAs and you're not just measuring core and shell, the interior walls actually have a really high embodied carbon. And so there's certain things that we can do to change our designs without totally redesigning things. So one of the things we noted is that within the metal studs, we tested many different options here for different spacing, as well as different types of insulation if you need it for acoustics, and then different types of studs. And then we decided to come up with these kind of industry best combinations where you can just start to select specific materials without changing your total, without inherently changing kind of how you already do your construction practices. And then we kind of came up with this reimagined combination that is, well, maybe in the future we could start to move this way to really start to reduce our embodied carbon. And so what those are, we have those for the metal studs and for the wood studs. For the industry best, we found that if you had an embossed stud with 16-inch on center, and if you have to have insulation, use glass wool, and then use a low carbon, you know, gypsum board like EcoSmart. And then reimagined, you know, we're saying, can you use 24-inch spacing on studs? Can you use cellulose insulation? And instead of gypsum board, can you use MDF? Because we found that gypsum board has a pretty high embodied carbon, and once you start to switch to wood-based products to get that biogenic benefit, you can actually really reduce right here your embodied carbon. And so same with wood, it's kind of a similar, you know, use the lightweight gypsum board, and then if you can also still use the MDF. And so one thing to note though for partitions is these were all done for a 13.5 foot or high floor to floor. And so based on your floor to floor heights, there is some slight differences on limiting heights of stud gauges that might affect a little bit of, if you're kind of on those extremes ends of a really high floor to floor height or really, really low, kind of maybe a renovation floor to floor height, some of the specific answers might change. And that's something we're going to add on potentially as kind of the next iteration as some of those options. And again, you can kind of use that same calculator here. So if we took, this is our kind of current standard at Payette that we select here if we're doing interior insulation within our interior walls, where we're typically using that 16-inch on center embossed studs with mineral wool and gypsum wallboard kind of standard. That's what we're currently using. But if we just change it to this kind of industry best, we can get a 33% reduction by switching to that low, the kind of the EcoSmart gypsum board. And then if we can switch to that kind of reimagined, we can get 189% reduction. So this kind of leads to some of these takeaways that we started to propose to our office, like where can we, you know, use wood and biogenic products as a, you know, so it could be using that MDF or the wood studs, but also it could be that the framing on the glass partitions, the wood helps to offset some of the high embodied carbon of the glass. And then can we, or you know, redesign your standard wall details to kind of take advantage of some of these materials and things that are already out there, just so we can have a baseline embodied carbon reduction.